In this lecture, we will examine two concrete examples to better understand how adaptive layouts work in practice. Let's assume that when the screen is in portrait mode, vertical, we want the layout to be divided into two parts, top and bottom. This is case 1. If we rotate the screen, the layout is still divided into two parts, for example, blue and green, and the division remains horizontal. This is case 2. However, if we want the screen to be divided into two vertical sections side by side, which is K3, we cannot simply keep using the same layout structure. We cannot rely on a column, but when the orientation changes, we need to switch to a row. The code we need is quite simple. The dedicated class adaptive layout defines a list of two colored boxes, one green and one blue. Within the build method, we define a variable called orientation, which is initialized using media query .orientationOf_context. Then, depending on the value of this variable, we choose the layout, a column that displays the two elements one on top of the other, or a row which displays the elements side by side. Now, let's consider a more realistic example. According to Flutter guidelines, when working with small screen width, such as a phone in portrait mode, it's recommended to use a bottom navigation bar. For larger screens, such as tablets, it's more appropriate to use a navigation rail, which can be seen as an evolution of the traditional drawer we have already encountered. We need to manage two different layouts, a bottom navigation bar and a navigation rail, which can be compact or extended. We split the code into two files. Even though the navigation bar and the navigation rail represent the same elements, they require different widgets, navigation destination and the navigation rail destination, respectively. To avoid duplicating code, it's better to define the shared data in an independent way and place it in a dedicated file called data.dart. In this file, we define a class called appDestination, which has three attributes: icon, selected icon, and label. We also provide a constructor where all the three attributes are required. Then we use this class to create the destinations needed in the app. Each destination includes an icon, a selected icon, and a label such as Home, Profile, and Settings. The icons are chosen from the standard material icons set. We can now move to the second file, the standard main.dart. We need to import two things, the usual material.dart and the previous file, data.dart, that contains the shared data we defined to avoid code duplication. The main function remains the same, and we use the usual myapp. We also introduce how to style the UI. We use three main parameters: theme mode, which defines the mode we want to use. It can be thememode.dart, thememode.light, or thememode.system, meaning the app follows the device settings. Theme, which defines the appearance for light mode. Dark theme, which defines the appearance for dark mode. To clearly distinguish the two modes, light and dark, we use colors generated from different seeds. For example, a deep orange seed for light mode and an indigo seed for dark mode. The brightness is set accordingly, light in the first case and dark in the second. The home parameter of Material App is not the usual scaffold. Instead, we use a special purpose widget called Home Switcher. The role of this widget is to decide which layout to display. Inside its build method, we define a Boolean variable called isPhone, which is true if the device width is less than 600, and false otherwise, indicating a tablet. We also define a simple list of strings, home, profile, and settings, which are used as placeholders for the pages. Based on the value of each phone, the build method returns either a phone home widget or a tablet home widget. In both cases, we pass the list of titles so that the corresponding layout can create the page structure. In the second part of the slide, you can see a small auxiliary widget called Page Shell, which acts as a simple placeholder for real content. It uses a card widget combined with some padding to display the provided text in a clean and structured way. Then we have Phone Home and Tablet Home, two stateful widgets. In this case, we focus on state management through the two state managers. The state of Phone Home includes an integer called selected index, which is used to identify which of the three page shells is currently active. In the build method, we return the usual scaffold. Here, we reuse the idea of safe area, and inside it, we place a page shell, whose title is taken from the initial list of three titles using the one that corresponds to the current value of selected index. Then, inside the scaffold, we define the bottom navigation area by creating a navigation bar. Once again, the selected index attribute is set using the class variable, while onDestinationSelected is the usual callback that calls setState to keep the GUI updated and simply changes the current value of selected index to the new index selected by the user. The three destinations are defined in a simple way. We reuse the initial destinations list declared in data.dart, and we map it so that we create three different navigation destination widgets. The code is therefore quite compact and avoids unnecessary duplications. If instead we consider the tablet home state, things are slightly different. We still have a scaffold and we still use the selected index attribute, whose initial value is 0. However, we must also introduce a Boolean called rail extended, because we need to know whether the navigation rail is fully expanded or not. Inside the safe area, once again we create a row, so the elements are arranged horizontally. The children are as follows. First of all, we create the navigation rail. Here again we have several parameters: selected index as before, extended to indicate whether the rail is open or not, and onDestinationSelected, which is basically the same as before, since inside setState we update selected index. We also define the leading widget, which is an icon button placed at the top of the rail and used as the button that, when pressed, opens or closes the rail. Then we have the label type. Here we can use the ternary operator and make the choice based on rail extended. The destinations are defined as before, and once again, we need to convert the result into a list, because the map operator does not directly return 1. In the list of children, we also have a vertical divider, which is yet another useful widget, and an expanded widget, which is used to display the page shell according to the same rule as before, namely by occupying all the available horizontal space. This realistic example of adaptive layout shows how to apply what Flutter suggests and concludes this second course.